Okay, so hopefully in the last slide you see it says take a break. Because this is going to go into more depth than what you're going to have to know and spend a lot of time on. So all the material up to now is sort of a background to get us going to really what we're going to be using almost for the rest for 3/4 of the rest of the semester. And what we're going to do is we're going to pull out periodic table. On the next slide, there'll be a periodic table, and I'll be relating to that. So, if you have a periodic table, I would, if you can, get yourself a periodic table. If you have the book, you can look at it. You can easily look online and get one. But you're going to have a periodic table available to you for this class. And so, I don't know, get one and have it available for you to always take a good look at. So because we'll be using it a lot in this class, and you'll be able to use it on the test and so forth. On the test, I would suggest I really would like if you allow you to you're allowed to use the periodic table, but I would ask that if you mark up the periodic table, is add things to it to help remember. I would ask you to not use the one you mark up for a test. Use a blank periodic table. So have a test periodic table and have your own working periodic table. And on the next slide you'll see one that that I'm using for this lecture. If you want, you can use that one, and you can download it. But if you can, get a periodic table now, and let's take a quick look at it, because this is going to help us get into the next thing that we need to know about pure substances. So pure substances, if you go back and look at that diagram where I split off pure substances and mixtures, you see that pure substances will be broken into two parts: elements and compounds. And so that's where we're going to go into now. So if you look at the periodic table, the table has quite a bit of information, and over the rest of the semester, we'll be unveiling some of the mysteries of it. Okay, so if you just look at it, there's really cool things about it. I mean, if you look at it, how it's situated. So, like I said, take a look at the periodic table, and right off the bat, what you notice is that there's columns and rows. Okay, now the columns. Okay, so the rows are just the first row has hydrogen and helium. Second row there's 8 squares, and each square on the periodic table represents an element. And so an element is a substance that cannot be broken down into any other element. And that has its own unique property. So if you break down, you take your physical separation techniques and break down a substance to where you can't break it down anymore physically, you will have an element. Okay, and the element will have its own chemical properties. Now, so each square will represent a chemical property. An element. And you notice is that if you look at it, each one, they'll have a name, they'll have a letter or 2 letters, and then they'll have a number on the bottom and a number on the top. And we'll go over each one of those. Now, if you look at the columns, you'll notice the columns are it's not just a table. It's just, a 4x8 table. This is that there's, over the left-hand side, there's 2 columns. They have the same height. And then there's 10 columns in the middle. They have the same height. And at the end, there's 6 columns that have the same height. So, and then at the very bottom, there's that extra section that has 14. Okay? So you have 2, 10, 6, 14 are these set of columns. Well, if you look at it, if you divide each, if you had 2, 10, 6, 14, divide them each by 2, you get 1, 5, 3, 7, which are odd numbers. And they're not in order, but still, there's 1, 3, 5, and 7 are how the periodic table ends to be set up. Now, we didn't come up with that. I mean, we didn't decide to have the periodic table what. That's how it revealed ourselves with it. Okay, so, and then there's all these other things that we're going to see inside it as the semester goes on. So let's take a little bit more here. So now in the next slide will be a periodic table, but in a lot of periodic tables there's a zigzag line or staircase on the far right hand. On my periodic table there'll be the yellow colored elements. This is a point of division, one of the trends of the periodic tables, and this is one of the most important things that you need to know about the periodic table. And all the stuff I talked about up to this point about periodic table, you don't have to know right now, but this one you do. The elements left of this zigzag or staircase, or these yellow colored, are called metals, and the elements to the right are called nonmetals. Okay, so that's how they are chemically in terms of periodic table. But also physically, you probably know when you have a metal. A metal is shiny, okay, has it's hard, it's good conductor of electricity and heat, okay. On the other hand, nonmetals, they may not conduct electricity or heat all too well. They're not usually found as a solid. They can be, okay, but they can be found as gases or liquids. Now, when we say they're states of matter, it's the states of matter at what we call standard conditions, and standard conditions are about 70 degrees Fahrenheit, which is 25 degrees Celsius, and normal air pressure. Okay, so if you have a lot of periodic tables will have, when you look at them, is that they'll have a way of this designating if they are being a gas or a liquid or a solid. So left hand side of the table we call metals, right side we call nonmetals. And those are going to be chemical terms, okay. Now, and they're opposite in terms of how their chemical behaviors are. And they will have physical difference as well. Like I just said, the metals are good electrical heat conductors and are solid and shiny. Well, the nonmetals don't have to be, and they can be in different shapes and forms, different states, and so forth. The periodic table as we know it was derived by Dmitry Mendeleev 150 some odd years ago. And it was interesting how he did it. He just sat down with the elements, the cards with the elements, names and properties on them, and he moved them around. And what he ended up doing is he ended up putting elements that have the same chemical properties in the same column. And then the rows are designated by their mass. So elements going from left to right get heavier, and all the elements in a column will have similar chemical properties. For instance, I told you earlier, a chemical property of oxygen is when you combine it with paper, it forms carbon dioxide and water. Another property of oxygen is when you put it with other molecules, it will often gain 2 electrons. Sulfur is in the same column as oxygen, and when you combine sulfur with certain elements, it also will gain 2 electrons. Right. So remember this. This is one of the key things about about our periodic table is elements in the same column have similar chemical properties. So columns are also known as groups, and rows are known as. All right, so here's the periodic table, and again, I want to show you parts to it here that'll help, that you'll need to know for definitions and so forth. Okay, so each square represents an element, and the element has different parts to it in terms of its square. It has the atomic symbol. Okay, it has the atomic name. It has its atomic number. The atomic number is also the number of protons, which we'll get into in a minute. And if you notice, as we go left to right, so in the bottom here is the average atomic weight. So why it's average, we'll get into in a few weeks. Okay, so not all hydrogen atoms have the same weight, mass. Most of them have a mass of about 1, but some weigh a little bit heavier. So this says 1.008. What that means is its atomic weight is 1.008 atomic mass units. Okay, so an atomic mass unit is the mass unit of what defines atoms, and we'll see that that a proton weighs 1 atomic mass unit down the road. All right, so you also notice here what I told you about the columns. Here's these 2 columns, and you have these 10 columns, and you have these 14, and these 6. Okay, here's your staircase or zigzag line. Everything left of that is a metal, everything right to that. And that's what you're going to have to know now as we go on. Now, some other things that I want you to know as part as the definitions go, vocabulary, and again, you'll be able to study this in Quizlet, is... Okay, so I had to take a break there. Okay, so where did I leave off? I'm not sure, but okay, so what I want to do is just give you a little bit more about the structure of the periodic table. You have to know these for definitions for a test. Okay, the first 2 columns. The first column is also known as the alkaline metals. And I'll have a list at the end of the PowerPoint giving a list of these and a link to where you can practice these. Second column is called the alkaline earth. And alkaline is spelled ALKALINE. Okay. These guys in the middle here, from column 3 through 12, are called the transition elements. The bottom here are called the inner transition. Now you'll notice is that this square here, this blue square, and number 57, this is actually where these guys belong. So we take them out so that the table doesn't extend too far to the right. So we just bring them down here. Okay, this last 6 columns are called the first 2 and the last 6 columns are called the representative elements. And just a couple more things here. The last column is called the noble gases, noble, N-O-B-L-E. Okay, the second to last column are called the halogens, H-A-L-O-G-E-N. And again, there'll be a list at the end of the PowerPoint today. But the main thing you got to know here really is that the elements right of this yellow are called nonmetals, and the elements left of this yellow are called metals. These guys in the yellow are called metalloids because they sort of have behaviors of both nonmetals and metals. Hydrogen, we're going to actually move hydrogen over to the non-metal side. Okay, so what we can do is we can put it right over fluorine. And it turns, now I told you that all the elements in a column will have similar chemical properties. So if you put hydrogen above fluorine, that's saying it has a similar chemical problems as all the elements here, and it does, but it also has similar chemical properties as guys in the first column. So hydrogen can move depending on how we look at it, but for now we're going to move it over here to the nonmetals. So that's what you have to need to know now, and we'll get more specific about these. The other thing you really got to know is the number of protons that never changes for an element. Hydrogen always has one proton, and that's its atomic number. And usually the number of electrons an atom is equal to the number of protons, and we'll get into that in a little bit. So let's take it like nitrogen. Nitrogen will always have 7 protons, that's its atomic number, and usually it has 7 electrons. Now there's neutrons as well, which we'll get into in a little while, in a couple weeks. All right, so here you go. What I just talked about. So I told you that columns are called groups. And first column called alkaline, second column alkaline earth, 17th column the halogen, 18th column is the noble gases. I told you different colors states, which is not on this periodic table, but on a lot of periodic tables. All right, the first 2 columns and the last 6 are called the representatives. Elements 3 through to 12, 3 through 12, those guys in the middle are called transition metals or elements. And then the elements at the bottom are called intertransition metals. Okay, at this point, we'll go into more specifics. So make sure that you what you'll be able to do is practice these definitions using the Quizlet I give you at the end, and along with this in the announcements when I give you the link to this PowerPoint. Okay, classifying pure substances. Now if you go back and look at the that structure, that picture I gave you near the beginning, where we're separating matter into 2 parts, pure substances and mixtures. Mixtures can be broken down into heterogeneous and homogeneous. And then we said is that chemistry doesn't deal with heterogeneous mixtures, okay, because a definition of chemistry is how to make or break pure substances. So we're going to spend the rest of our time talking about pure substances. Now, pure substances can be broken into 2 parts as well, into elements and compounds. Right, and this is how they're found in nature. So you can have a pure element all by itself, like you have you have an ingot of gold. You could have helium gas. Okay, and when you have those situations, you can have the atoms are all by themselves. Okay, now elements also can form molecules, and we talked about that a little bit already. So we remember the definition of a molecule is 2 or more atoms chemically combined. And they'd be the same element or different element. When they're the same elements, they're called elemental molecules. And there will be a type of elemental molecule that you're going to need to know that are called diatomic molecules. And we'll go over that in a minute. Okay, the compounds we'll have two types of, there'll be two types of compounds. There's ionic compounds. So let's go back to compounds first. Compounds are molecules that, so remember, a molecule is two or more atoms chemically combined. A compound is when the atoms are different elements. Okay. An elemental molecule is when the atoms are the same. So when you have a compound, there'll be two types of compounds. One is called an ionic compound. And these will have a metal in them and a non-metal. So they'll have something from the left side of the table and the right-hand side of the table. And then there'll be another type of compound called a covalent, and will be only made out of nonmetals or hydrogens. So only from the right-hand side of the table. So that's the first thing you have to do is that if I were to give you, write out a chemical formula or chemical name, you first of all have to tell me if it's ionic compound or covalent. That's the first thing. So ionic compound will have something from the element from the left side of the table and the right hand side of the table. The covalents will have it only from the right hand side of the table. Okay. Now, so elements. We're not going to, you don't have to know. There's going to be just a few things you have to know about the elements. Few of the elements. And these, what I want you to know are the diatomic molecules. So these are diatomic molecules are elemental molecules. That means they're made out of a element. And there's going to be 7 of them, and you'll see why in a minute. Why the number 7 might help you remember. So there's N2, O2, F2, Cl2, Br2, I2, H2. Their names got this switch, should be formula and the name, and probably switch that in a second here. So the names of these are the same as the element, which can be a little confusing. So if I said, get me some nitrogen, do you mean N2 or N? Well, usually when we say, get me some nitrogen, like for a chemical reaction, you're talking about N2. All right. I call these the 7, and you'll see in a minute is that they actually form the number 7 on the periodic table with a slight exception. Okay. So you have to know these 7, their chemical formulas, and their names. And these are called diatomic molecules. So from here in, what you're going to have to do is you're going to have to know the names. If I give you a name of a molecule, either elemental or compound, you're going to have to tell me its chemical formula. So if I say nitrogen, you'll say N2. If I say Cl2, you'll say chlorine. And notice they keep the name as their element. Okay, so here you go, 7. If you notice, you got nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And they're on the right-hand side of the table. They're nonmetals, okay, and they form the number 7. But if you look, there's only 6 here. 1, 2, 3, 4, 5, 6. Okay, the other one is hydrogen. It's not in this 7. Okay, so that makes a 7, but you have to remember the 7th one is H2. So you have N2, O2, F2, Cl2, Br2, and I2, and then H2. So those are diatomics. All right. Okay, now at this point, you may want to take a little break, and because it's going to be kind of intense. but maybe after this slide take a break, uh, because this is where there's going to be a lot of, you're going to have to do a lot of knowing what's going to take place here. And you may want to go over this several times. All right, and I'll send you out a worksheet on what you need to study in terms of up to this point. But mostly what you need to study is the definitions. So the definitions are going to be, again, in Quizlet. I believe there's 38 definitions, and they're flashcards, and you can self-test yourself with these over and over and over and over. You will be given a test. I don't know exactly when, but on these definitions. So make sure you're working on them, and I'll let you know when that will be. Okay, so now on to the next thing. Okay, so I told you that there's two types of compounds, ionics and covalents. So ionics will have, so let's take a look at this diagram. Just like the other diagram, it's kind of a tree diagram, or a decision-making diagram as well. So what we're going to do is be able to come up with names and formulas for ionic and covalent compounds. So the first thing is ionic compounds will always have an element from the left side of the table and the right side of the table, while nonmetals will only have it on the right side. All right, now, and then we have our ionics and covalents. Okay, the way that this is going to work is we're going to go over the covalent compounds first, then follow it with ionic. The reason I am doing it this way is covalent you have to memorize. Okay, so there's 5 different categories, and you'll see I call it 1, 2, 3, 4, 5, and I'll explain why I have these numbers underneath later on. But once you've decided if it's a a covalent, it's got to be one of these 5 categories, and you have to memorize it. Will not be figuring these out. You'll have to say, oh, I recognize something about it that tells me that it's alkane. I recognize something about the the compound that tells me it's a polyatomic ion. And there will be a Quizlet of these. I think there's about 20 of these that you're going to have to memorize. And that may sound overwhelming, but it turns out that there's patterns to help you remember these, and I will be going over these. Right, once we get done with the covalents, we will go to ionic. Now, ionics are different. This is that you will have to figure these out. There will not be memorizing. Okay, there will be some memorizing, but you'll be figuring out. So one of the big differences between ionic and covalent is that covalent is memorizing. Ionic is method, okay? So we'll do covalent first because that's just, you're going to have to put your nose to the grindstone and study these. And ionic, you're going to have to need some help studying it. And I have a program that will help you study these and practice these, as well as the covalents. All right, again, like I said, the first thing you have to do is determine if you have covalent or ionic. So first of all, you have to see if the way to do that, I suggest, is first is to see if it's ionic or not. And again, if you have ionic, it has to have a metal in it. So if you're given a compound, that means that it has 2 or more elements in it. You have to decide if it's ionic or covalent. What I would do is suggest first to see if it has a metal. So the metal would come first in the name or the chemical formula. Now, chemical formula is it represents how many of an atom of the element are found in the molecule. So, first thing you would want to do is see if it has a metal in it. Well, if you're given the name of a compound, one way to tell if it has a metal in it is look at the first word, and if the first word ends with IUM, you're pretty sure that it's a ionic compound, because metals are well, there's a couple nonmetals that have IUM in them, but anytime you hear IUM, it is probably going to be a metal, like sodium, lithium, calcium, strontium, beryllium, and so forth. Now, there are a few metals that don't end in IUM, but I'm pretty sure you would know that these guys are metals, like copper, lead, iron, tin, zinc, silver, gold. And so not all of them end in IUM, but the ones that don't, you're probably sure that you do. Now, one of the things I'm going to make it kind of easy for you guys is that the only metals, now most of the periodic table is metal, so about 80% of the periodic table is metal. We're not going to deal with all 80% or 85 of those. We're only going to deal with the metals in the first two columns and these 6 that are in the middle: copper, iron, zinc, silver, lead, aluminum. So when you look at a chemical name or formula, look in the first two columns, and then if it has from the first two columns or is one of these 6, you have an ionic compound. If it doesn't have elements from the first two columns or these 6, it is a covalent molecule. Right, so let's get into the covalents. Right, from the above diagram you saw that there's 5 types. There's common, alkane, acids, and there'll be 2 types of acids: binary and tertiary, polyatomic ions, and binary covalent. We're going to go over each one of these, and again, I will give you a link at the end of the PowerPoint and also on the announcements for you to help study these. All right. The order that I present them is also important, at least the way I like to think about it. Now, one of the key things right off the bat is whenever you hear the word binary, it means it just has 2 elements in it. And if it says tertiary, it means it has 3 elements in it. Okay, now some of these, like the commons and alkanes, they might have 2 or 3 elements in them, but we don't call those binaries, okay? They have their own special names. So what we're going to do is start out with the commons, then talk about the alkanes, acids, and then the polyatomic ions, then finally covalents, binary covalents. Okay, the commons. These are molecules we run into almost every day and can be referred as our household as well. So common or household. So here's what you got to know: water, H2O, ammonia, NH3, acetic acid or vinegar. You can use this formula right here: C2H4O2. Glucose, which is a kind of sugar, C6H12O6, and hydrogen peroxide. So there's no really rationale between how these guys relate to each other. You just got to know. So water, you know, is H2O. Okay, ammonia, you're going to have to know it's NH3. And so forth. Okay. All right. some things about chemical formulas. Chemical formulas have two components. They have a chemical symbol of the element, and then the subscript represents the number of atoms of each of the elements. So H2O means that there's a hydrogen, an oxygen, and there's two hydrogens and one oxygen. So just like in math, if there's a 1, we leave it out. If we didn't do it, it would be H2O1. But again, like in math, we leave it out. So we write as H2O. So if you don't see a subscript, it means there's a 1 there. Okay, the next ones are the alkanes. And there's 10 of these. These are a subset of organic compounds. If you go further on into chemistry, eventually take organic chemistry, or if you take Chem 111, you will run into these again. All right, so there's 10 of them. And let's go over each one of them, and let's see if, and now that might sound overwhelming that there's 10 of them, but you'll notice that there's patterns. Okay, so so let's start. I like to start out when I do this on class. I like to start out with C5H12 because pent means 5. So 5 carbons. Okay, ane means it's the alkane. So if you notice, these all end in ane. The name ends in ane. And the first part of it, or the prefix, tells you how many carbons. So pent is 5, so 5. Hex, 6, 6. Hept is 7, oct, 8, non, 9, dec, 10. All right, now the first 4, the first part isn't going to be like monoane or diane or triane. These were named before we knew about their structures. These guys are methane, ethane, propane, and butane. One way that helps me remember these is mnemonic, okay? Meat eaters prefer bacon, MEPB, or beef, whatever you want, or beer. So methane, ethane, propane, butane. And then the other 6 follow. The prefix tells you how many carbons. All right. So let's go to chemical formula. So methane. So this is actually a good place to start. It start out with methane, is CH4. Okay. Now if you notice, every time you add 1 carbon, you add 2 hydrogens. So methane start out with CH4. Ethane is C2, but then you add 2 hydrogens. Okay, propane, you add 1 more carbon, and then you add 2 hydrogens. Okay, if you notice, if you start out with methane, you can get the rest, because every time you add 1 carbon, you add 2 hydrogens. Now there's a little formula for that. You don't have to know it if you just follow this pattern. You can just write them out. Okay, is for every carbon down here at the bottom, for every carbon, there's twice as many hydrogens plus 2. So let's take a look at propane. So propane has 3 carbons, so hydrogens should have twice as many. So 6 plus 2 is 8. So there's those 10. So now you have 15 names and formulas to memorize. Okay. Now these all have 2 elements, but we don't call them binary. These are called alkanes, right? And notice they just have carbons and hydrogens, and they have it in that specific pattern. The names end in ane. Right, next group is the polyatomics. Okay, there are 5 of these. All right, and here are the 5. There's phosphate, sulfate, nitrate, carbonate, and then an odd one, hydroxide. Now the chemical formulas, PO4 with a 3 minus, and we'll talk about what 3 minus means in the future, in the near future. But a 3 minus is So what I'd like to do in class is circle this or put in parentheses, and because this whole thing has a 3 minus on it. SO4 with a 2 minus, NO3 with a minus, CO3 with a 2 minus, and OH with a minus. These are really, really important, okay? Spend lots of time memorizing these. These will probably get one of the most use for the rest of this for the next 4 weeks, 5 weeks, all right? Notice that these end in 8 except for hydroxide. The other thing is the name tells you what element's in it. Phosphorus, phosphate. Each one of these have oxygen in them. So the polyatomic ions have oxygen in them. They all have negative charges. Okay. They have more than one element, obviously. Okay. And they're the only covalent molecule that will have a negative or positive charge. All right, so you just got to memorize these. Okay. 8. Now we're going to see in a minute that we're going to be using polyatomics again when we talk about acids, tertiary acids, and tertiary ionic compounds. So these are really, really important. Okay, so make sure you spend a lot of time memorizing these guys. Okay, know their formula and their charges. Now, is there any way that can help you remember these? All right, so here is maybe a way to help you memorize. Right, and so this is column 2, this is row 2, and this is row 3 of the periodic table. So carbonate and nitrate both have 3 oxygens. CO3, 2 minus, NO3, 1 minus. These two both have O4, PO4, SO4, but they have different charges, 3 minus and 2 minus. So maybe this, and then the odd guy, hydroxide, OH minus. Okay. So this might be a little trick to help you remember. CO3, NO3, 2 minus, 1 minus, PO4, 3 minus, SO4, 2 minus. The corners are 2 minus, 2 minus, and 2 minus. So CO3, 2 minus, NO3 minus. PO4, 3 minus, SO4, 2 minus. Again, make sure you spend a lot of time remembering these. 8. 8s, except for hydroxide. All right, the acids. There are 2 types of acids, binary and tertiary. So binary means it has 2 elements, and tertiary means it has 3 elements. The binary element acids will have, let's go over them. There's 4 of them. Okay, now let's look at the chemical formula. Acids will always have hydrogen in front, H in front, all right? So that's how you can tell if it is an acid. The binaries will just have 2 elements, and the elements come from the 17th column. So if you look at the periodic table, you'll see F, Cl, Br, and I. Okay, their names will all start with hydro. So binaries will start with hydro. So hydrofluoric, and again, the name fluor tells you what's in it. Fluorine. Hydrochloric, hydrobromic, HBr, hydroiodonic, HI. So again, here's some things to notice. Names all start with hydro. They all start with an H in their formula, and they have elements from the 17th. And there's 4 of them. Okay, tertiary acids. It's kind of lightning out there. I might have to take a break here if it gets shot down. Okay, so tertiary acids. Tertiary acids have 3 elements, and there's only 4 of them that you need to know. Just like in the binary, there are only 4. Again, they all start with H, and again, they have acid in their name. So that's a good way to know if you have an acid. It has acid in the name or starts with an H. Okay, the other thing about these guys, so there's 3 elements. So this first one, phosphoric acid, they don't start with hydro. They have 3 elements. They have the H, a P, and O. Now, if you notice, is that this PO4 looks like what we just saw with phosphate. Phosphate is PO4 3 minus. Well, phosphoric acid is phosphate without the 3 minus. Instead of having 3 minus, it has 3 hydrogens. So the number of charges is replaced by the number of hydrogens. So if you know those 4 polyatomic ions, the 8s, phosphate, sulfate, nitrate, carbonate, you can figure out their corresponding acid. So PO4 3 minus gives you H3PO4 phosphoric acid. Sulfate, SO4 2 minus, gives me H2SO4 sulfuric acid. Nitrate, NO3 minus, gives me HNO3 nitric acid. And CO3 2 minus gives me carbonic acid. Again, things to notice, these are made of polyatomic ions with hydrogens attached. Number of hydrogens equal to the charge of the polyatomic ion. The 8 becomes ic acid. And hydroxide, we don't give it an acid. It technically can, but we're not going to give it one. Okay. So up to this point, we have 5 commons: water, ammonia, glucose, vinegar, and hydrogen peroxide. You have the 10 alkanes: methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. Then you have your polyatomics: phosphate, sulfate, carbonate, nitrate, and hydroxide. And then you have your 8 acids: hydrofluoric acid, hydrochloric acid, hydrobromic acid, hydroiodonic acid. And then your 4 tertiaries: phosphoric, sulfuric, nitric, and carbonic. Okay. So up to this point, whenever if you're given, you have a covalent compound, what you should do is, you need to do is check if it's one of these 4. Okay. Now, there'll be times when you will not, it'll be a covalent compound, it will not fall into one of these 4 categories. But it's covalent. So what is it then? Well, it's probably going to be a binary covalent. If you know you have a covalent compound and yet it doesn't fit into these 4 categories, then it's more than likely a binary. This is default. So if it doesn't fit anywhere else, it has to go here. These are fairly easy to figure out. Their names and formulas. They just have 2 elements, and the name and the formula tell you exactly who's in them. It's kind of pretty. Okay, there is one little caveat, but we see that in a minute. For instance, CO2 is carbon dioxide. Di means 2. So you may ask, well, why don't we have a mono in front of the carbon? Okay, if the first element has only 1, you leave off mono. Okay, if there's 1 of the second element, you will use a mono. All right. For instance, if you had S2Cl3, so there are 2 S's, so you would say disulfur, and there's 3 chlorines, so you would say trichloride. So the second element will end in "ide." Okay. So you use prefixes. Now this is the only place besides the alkanes that you use prefixes. Don't use prefixes anywhere else. Okay. When we get to ionic compounds, you won't be using them there. The only place you'll be really using these will be binary covalent. Okay, and this is your default. So there's your covalence. So you have to memorize your commons, your alkanes, your polyatomics, and your acids. Okay, but binaries you can't memorize, but that's okay because if you know their chemical formula, you can figure out their name by using prefixes, or the name's going to tell you how many of each of the elements. Like if I said you had tri boron tetrafluoride, so that would be B3F4. So we'll be using, so that's it. Okay. All right, so there's your covalents. Again, they're memorized for the most part, except for the binaries. And there's tricks, and you just have to study, study. And I can't say enough about that. These are more important than the definitions that we've had. The vocabulary, this is more important for us to move forward. So make this a priority in terms of getting ready. This will be worth more points than the vocabularies. All right. So what we're going to do now is go to the Ionic. So this might be another point to take a break, and on the announcements for the link, I'll tell you what what times during the PowerPoint would be good to take a break. So what we're going to do now is go to Ionic and figure out their names and formulas.